Well, thank you everyone for coming. We're very excited to be here today together with Flower.ai, and Javier will give a demonstration on how Flower.ai, how to operate federated learning within myDRE workspace. And yes, to give you an idea about the program, so there will be an introduction about myDRE. Some of you already are familiar with it. And after that, we will go to an introduction with Flower.ai. And when that is done, also, we will start with integrating Flower.ai inside myDRE. So I would like to start with Johanna.
Thank you, Ardit. And well, welcome everybody to today. Let me share with you the correct slide so we can get actually started. Well, welcome everyone. My name is Johanna Akonen. I'm an operations manager at anDREa, and I'm excited to tell you today a bit more on what we do as anDREa as a company and myDRE as a product. It will be just a short introduction because everybody's more interested in actual implementation of Flower.ai and myDRE. So let's get to it. So what myDRE is it's basically ability to deploy workspaces for storing and processing data. Processing data is a headache stemming from duty of care that organizations such as university medical hospitals carry. Requirements coming from GDPR, collaborators internally but also externally, data issuing, information security. You have to stay compliant. You have cost control, and a new one on the list is also the European health data space, coming also with own set of rulings and standards and practices. Well, we all understand the complaints and we also hear them. This all results in more procedures, more paperwork, more policies, which in turn for the researchers who actually just want to do the research, it creates more red tape. We, as anDREa, provide a solution called myDRE, and we believe that it is a solution for here and right now. To enable researchers to do the thing that they can do the best themselves, and that is to do the research. So work has to get done, even though you have lots of things that you have to take care of in the meanwhile. So the mission statement that anDREa has is to unburden and empower in setting up processing environments for secondary use of health data in a sustainable way. What do I mean by that is we operate by buy with for principles. So everything we do as a company comes from or is inspired by the research ecosystem. So what is the need? That is what we address. We like to be seen as part of the bigger whole of the ecosystem rather than just a software company providing just another SaaS solution for you. And part of the vision statement is it is all about being here, now, and for the many. So we like to see ourselves as loosely coupled, but still integral part of the bigger picture. The picture that is depicted here is just to illustrate that this comes from one of our organizations that is working with us, just to depict that we are part of their bigger solution that they provide for their organization. And we are just a little piece indicated by the arrow on top as part of this. Like I mentioned, the ecosystem. So in the ecosystem of secondary health, use of health data, we like to position myDRE in the middle. So in the data processing part, and especially in the trusted processing environments that are still human-centered. However, as you can see, the blob around the picture is a bit blurred, so it sort of spills over into both parts, the data issuing, but also a bit of data storing. That is to indicate that we like to see ourselves as being part of the bigger picture and loosely coupled. So there are integrations possible, like we will see in a moment, with other systems that are also part of this bigger picture. And on the below panel, you see green boxes and red elephant in the room. That is basically to illustrate that within an organization, in a cycle of the system, you have governed systems for data gathering, data issuing, but where the problem arises is usually around data issuing and between data storing, so the data processing part. This is usually where the organizations, as we see them, have difficulty in organizing it in a governed way. That is where we fill in and provide a solution. To illustrate how myDREa is being used now, these are the numbers from the last month. So there were actively a bit above 1,300 users actively using the system across 26 countries. I always like to show this picture to illustrate that we are providing a solution in here and now. There are currently this many users that work with the system that we provide across 26 countries. So we enable collaboration. That is basically what I want to stress here. So what do we provide? What is a workspace that I just mentioned in my first slide? So you can see workspace as similar to an office space in a building with our services. The institution that you work for, the organization, can create spaces, office spaces, so to say, digital equivalent thereof, in their own digital building for specific purposes. So think of it as a project. But these are only accessible for invited individuals. These invited individuals can be part of the organization, but they can also be from outside the organization, residing, for example, in different countries. The guiding principle here is role-based empowerment. These spaces are tool and data agnostic, and the key is that the data is not brought to people, but the people are being brought to the data. So the data stays where it's supposed to be. And I would like to end by showing different collaboration possibilities that are possible in the current system. So we believe that thanks to the way we have set up our system, myDREa, it promotes collaboration and also working in a different ways, a bit like pieces of a Lego puzzle. There are millions of ways how you can assemble it, and that same holds true to myDREa. And today we will see a nice demonstration of Flower.ai within a myDREa workspace, just as another tooling of using other tooling within the system that is still under governance and can be seen as trusted. So thank you, everybody, and looking forward to the demo as well.
Thank you very much, Johanna. If there are any questions, you can use the chat, or you can also just raise your hand, and we will be answering to those. Are there any questions regarding myDREa that you'd like to address right now? And if not, as I mentioned, you can add it in the chat. Javier, please show us how Flower.ai can be connected with myDREa and what it can do.
Perfect, yes. As Johanna mentioned, so this presentation, the rest of the seminar is going to be split in two parts. First, I'm going to give a brief introduction about Flower and what it is and how it enables collaborative AI, whether it is training machine learning models or is using distributed data for maybe some AI purposes. And we're going to see how to do this through myDREa workspaces. But first, I'll give you a brief introduction about Flower and what we have been doing in the last couple of years, basically. So Flower is the unified federated learning framework for all things federated. It can be the standard federated learning, where one machine learning model or AI model is trained in collaboration in multiple nodes, but it can also be used for federated analytics, for example, where there is not a model per se, but you want to be able to gain some understanding on data that is naturally distributed and that cannot be moved from the location where the data resides. This could be a hospital where data is highly private and sensitive, but there are many other domains, like, for example, banking, education, and other type of organizations, both public and private. In all those domains, you can use some of the federated flavors that Flower supports. You can use it in multiple of programming languages, from standard programming languages like Python all the way to high-level frameworks like iOS or Android. And it supports many of the core technologies that are needed when you want to run these things in production, like secure aggregation, differential privacy, and so on. As we'll see in the demo, with Flower, Flower is not something you use only in production or only for research. It's a framework that is versatile enough that you can use it all the way throughout the entire development cycle. Maybe you want to start first prototyping your ideas with some synthetic data that is free of user information. Maybe you would be doing this on your workstation, for example. And then once you have a good understanding of what are the unique changes of your data, you can take that exact same code and run it in a deployment, like for where the nodes, where the data is, are distributed around the world. And in the demo, we'll see those nodes are myDRE workspaces. Flower is framework agnostic. And what we mean by that is that it is not opinionated on what tools you should use with Flower. You can use it with a variety of popular machine learning frameworks, but if your task is not machine learning related, you can still use other data science tools like sklearn, or more generally, Python or C++. Maybe you just want to use some visualization tools as well, like MLflow or TensorBoard or weight and biases. You can make use of all of them. One of the things we are the most proud of in Flower is our amazing community, which is truly global. For example, if you join Slack recently, you would have seen that we are close to 5,000 developers and researchers alone in this big public workspace. But there are many more. And a testament to that are the very big amount of public open source projects that are built on top of Flower. There are over 1,500 of those projects. And Flower, as I mentioned earlier, has been used extensively by researchers, collaborating many times in the open, asking questions on Slack or in Discuss, finding collaborators in those settings, as well as finding other maybe engineers working in production environments that share some tips on how they manage to implement certain features with Flower. Flower has been used for some of the papers that have been accepted in the top research venues in machine learning and data science, like ICLR, ICML, KDD, and others, also including those in the medical sector. And precisely the medical and health sector is one of the topics I want to give a bit more details on some of the projects we have been supporting recently, and projects that we were not supporting, but we heard from those leading the projects that they were using Flower to build some truly amazing things. Two of those examples are the NHS federated learning setup that Andrew Sultan put together. He involved the NHS and his team at the University of Oxford to run a federation involving over 100,000 data points, real data points. Another example is the FL for Health toolkit that researchers at the Vector Institute in Toronto put together very recently, and is one of the best libraries built on top of Flower to do federated learning for health. More recently, we ran projects where we show for the first time that you can do federated multi-organ 3D image segmentation. This was a pilot program project we ran with researchers from the University of Maryland. They won the best paper award in a workshop for medical imaging at CVPR. And now this project, we are extending it, and it's going to run in a version of it will run in a series of hospitals in the Baltimore area in recent months. Another truly global project we are helping run, is one through the Blood Counts Consortium. The idea of this consortium is, the federated learning project in this consortium tries to connect through federation a number of hospitals and medical centers around the world and federate with Flower the access of a very common medical test, which is the full blood counts test. And why is it important? It is important because when we are able to achieve a super large scales of data points, even for these very simple medical tests, we can use this information to better predict some more serious diseases. Like, for example, can we predict out of this test when a heart attack is going to happen, and other type of problems. For this in particular, we are collaborating with the University of Cambridge and a team that is also working in the Cambridge University Hospital. There are a multitude of centers involved in this consortium, and some of which that I believe they are using myDRE is UMC. So as we saw, there are multiple ways for working with us with Flower. One of the more popular ones is the pilot program, which is a free program where research teams in universities or in industry want to develop a project with us, and we support them. There are different. If that's not enough for the application you want to put together, because maybe it's very ambitious, or maybe because you want to take it to production, well, we offer also support programs for this. And if you want to build something super custom, we are also happy to build something custom that suits your organization. A bit of information about the pilot program. This is usually between 4 and 6 months program. It's free. The idea is that we help you refine a project that you want to run with Flower. This could be an entirely new project or something you want to federate for the first time. And the key benefit of this program is that we help you with technical challenges you might be facing, and also we help you frame the project better. Without adding too much promotion here, we also have a support program. And if you are more serious about taking federated learning to real setups, whether it is in research or in production, we also have a support program that we give a more dedicated support than what the pilot program offers. And some of those support mean building proof of concepts with you and talking to your engineering team and us in our engineering team will talk together and build it so it works out in the end. So before jumping into the demo, I just want to give a brief overview of how federated learning with Flower works in a distributed real-world setup. And this is important because we will follow these exact same steps when we show you the demo with myDRE. So in Flower, we have a clear distinction of what is the application and what is the infrastructure. The infrastructure is something that stays constant for long periods of time, and is something that a researcher or scientist doesn't interact with. This is something that the IT manager in your organization would launch or would shut down or would update whenever it is needed. So let's start with a simple setup where we have 2 super nodes. This could be 2 different hospitals, 2 different organizations in general that want to collaborate. And they are, each of them is a workspace in myDRE. They are attached to their own private data, and they don't necessarily know each other, but they have some agreement that they want to be all together part of a federation. The supernode is just a very lightweight process. You can think of it as a program that periodically asks another entity that we call a superlink, it periodically pulls messages, and these messages contain information such as you need to train this model on your local data, or evaluate this model on your local data and report the accuracy, for example. It is important to highlight that the supernodes themselves are the ones that initiate the communication. No information, nothing can be sent directly to these secure environments. Receiving something has to first be initiated by the supernode itself, asking, is there something I can receive? The superexec and superlink, they are two independent processes that could live in the same machine, or it could be in separate machines. They could be in myDREa as well, or it could be in a different cloud, or on premises in your organization. The idea is that if you are a researcher, you would write, as we'll see in the demo, two applications, which could be two simple Python programs. One is the server app, and one is the client app. The server app, what it does, it defines which nodes are going to be involved in the federation. It prepares the messages that will be eventually pulled by the supernodes, and then it defines, critically, it defines how the result coming from the supernodes get aggregated. For example, if the task is to train an image classification model, this supernode will train it with its own data. This other supernode will train the model with its own data. The result would be models that look architecturally the same, but they have different parameters because they have been trained with different models. So those two models will be received by the server app, and the server app will find a way to combine those results. We call that aggregation, and there are multiple ways of doing it, and there are multiple algorithms supported in Flower. How does a Flower federation start? The starting point is a command called Flower run, and what this will do will bundle these two programs, send them to an entity that we call the superexec. The superexec, you can think of it as the gatekeeper of the federation, and only those that are authorized to interface with the superexec will be able to send these programs. Once both the server app and the client app are in the superexec, the experiment, or the run that we call, will begin. And what will happen is that the code will be delivered to the supernodes. This code, which is written by the authorized researcher, what it does, it is task specific. It will do train an image classification model. It will do some regression on tabular data. It depends on the application. But the key idea is that this code has been written by the researcher, and if another researcher comes along, maybe another researcher from the team, maybe this researcher is interested in running a different set of experiments. For example, this lady here wrote an image classification training algorithm for images from X-rays, for example, and then he wants to use the same federation, the same silos of data to train an image segmentation model instead of an image classification model. Well, if he is authorized to run the application through this federation, he would run the exact same command, Flower run, and the code delivery mechanism will be executed in the exact same way. As you can see, even though there was a new experiment being run, we didn't have to restart the infrastructure. We didn't have to shut it down or anything like that. And this is only possible because there is a very clear decoupling between infrastructure and application, which in real world setups, it is fundamental, especially when there are other teams, other people involved in managing these systems. So this is the introduction I have about Flower. There are many more concepts that I haven't brought here, like there is support for auditing logs, traceability, and authentication. There is isolated task execution with containers. This is fundamental for proper deployments. And if you have any questions now, I'm very happy to take the questions. If not, we can jump straight into the demo. Okay, then I will jump straight into the demo. For that, I'm gonna stop sharing my screen. Well, no, first I'm gonna explain the demo and then I will share my whole screen with the code. So in this demo, the setup of the demo is as follows. There is a researcher that wants to train an image classification model for abdominal with abdominal CT images. These are images of organs like the liver, the pancreas, stomach, lungs, and so on. So the task is, out of these 11 total classes of images, can I classify it correctly, yes or no? And we know that this data is distributed. This data is going to be distributed into 10 different silos. This could be 10 different hospitals, 10 different research centers. It really doesn't matter. What is key is that this data cannot be moved. So it's not, we cannot move all the data and construct one big data set. No. The best, if there is no federation, the best thing each center, each hospital can do on its own is to train the data they have and then hope that that model is good enough and generalized to images that could come from anyone out there from the population. And we'll see that that's really, really challenging, if not impossible. So in this demo, which I'll be sharing very soon, there is some code that I will be sharing later with you after this seminar. And there is a very simple image classification model using these images. And if I was to simulate that setup I described, where every center only trains on the data it has, but then evaluates the performance of that model on the global test set, we see that the performance is very poor. So we see that the global accuracy, the local accuracy, it's still not very good. Like we see 40-something percent, 60%, maybe even up to 70-something percent. But that's only on its local validation set. If I take each of those models and evaluate it on the same global test set, we see that the performance goes down by a lot, even down to 20%, 30%, which is terrible. We'll see that with federated learning, because all these disjoint, isolated data partitions could be leveraged through FL. In that way, and only in that way, we can preserve the privacy of the data without moving it, and still be able to train a model that learns from all of these distributed data sources. And the example I will show now, without any fancy tweaking or anything, and the same model, we're able to achieve much higher accuracy. So this is how the demo is going to start. It's a setup where I'm running simulation. I'm a researcher and I want to get a feeling of how federated learning works. What will happen right afterwards is that exactly this same code, I will do what I showed in the previous slides. I want to run it for real in a real federation. For that, I will do Flower run as well. And because I will be authenticated with a super exec my code will be delivered to the supernodes, and the supernodes themselves, which are going to be myDREa workspaces, they have some data that I have already prepared. They will do the training of that image classification model. And we'll see essentially that it's really easy to put it together with myDREa. Okay, so without further ado, and by the way, feel free to ask any questions if you have some. If I'm going very fast with some parts, please tell me so and I will slow down. Okay, so what I'm going to do, I'm going to share my entire screen. Hopefully you can see my entire screen. And I'm going to move some things out. First, I just want to bring the code here. I'm not gonna go into details with the code or anything. I just want to show you that, well, the code is real. The slides I presented with the numbers are the real numbers. It's not something I invented. For example, we could generate any histogram of the data. For example, here I'm seeing what the zero partition of the data would be. There are, as I mentioned, 10 partitions in our dataset because there are going to be 10 supernodes. If I see another partition, well, it looks, the distribution over the labels is different. Writing the server app and the client app, you can see it here if I make it a bit bigger. It's really simple. For example, the server app can be written with just shy of 60 lines of code. In this case, my server app is running one of the most standard algorithms, which is called Fed_average, which what we will do, we'll simply take the average of the image classification models that are locally trained in the myDRE workspaces, take the average and obtain a better model, or at least that's the hope. Let's say that before running the thing through myDRE, I want to get a feeling of how this would work with some data I have available in my workstation. So I could run all this in simulation by simply doing Flower run. I will show you how to run it in myDRE immediately. But the key idea is that it is really as simple as that. And while this runs, I'm going to show you what the client app code is. Again, it's fairly minimal. You can see not even 60 lines of code. If you have already experienced working with Flower, you know that to write your client app, normally you only have to write two functions, or two methods, better said. One is feed, that does local training with a given set of parameters, and the other one is evaluate, which does local evaluation with a given set of parameters. Currently, the code here is running in simulation, so it's running all in the machine and where this code lives. And just with 10 rounds, I can see, well, that the accuracy by running in simulation with federated learning has reached 60%. And if we go back to our slides, well, 60% is already, with just 10 rounds, is much, much better than any of the other approaches. If you run it for a bit longer, it will go to 70, as I showed there. But this is simulation. Let's say I'm happy with my code and I want to run it now in a real deployment with myDRE. How do I do it? So the first thing to do is go to myDRE, and I will show you here my workspace. Here, I'm going to make it a bit bigger. Here I have two standard virtual machines. They are very lightweight machines. You can see 2 cores, 8 GB of RAM. We are running Ubuntu. And as we'll see very soon, they are very standard machines. If I want to be able, if you recall from the slides, one of the things that maybe attract your attention is that my supernode in myDRE is connected to the superlink. And this superlink can be, in this demo, it's going to be in a different cloud, but it could be anywhere else. It's really up to you to decide. So in order to be able to establish this connection, so the supernode can initiate the connection to the superlink, we need to grant some external access. So we need to essentially whitelist one IP address. If you have access to see this tab in your myDRE workspace, you know that here you have URLs that are allowed, like for example, Anaconda, to pull packages from Anaconda, and so on. What I have done for this demo is I'm whitelisting an IP. This is an IP of a machine for this demo. It's a machine that is running a server from a cloud provider in Germany. here is where the superlink is running, and it's listening to this port 1992. And this is the only thing I have needed to do in order to set up my myDREa workspaces in such a way that they can communicate with the superlink. So let's see the myDREa workspace as well. Here I have, one myDREa workspace, and here I have my other workspace. I have two workspaces, and you can see they are, perfectly functional. There is no trick here or anything. And what I have done in this, let me just pull this away. What I have done here is that this workspace on the top, which I simulate with this, it has some data, one of the 10 dataset partitions I was talking about. And this one below has a different one. And you can see how different they are based on this histogram. You can see, right? For example, here we have many images of liver, almost no images of these other classes like femur or heart or lung. On this other partition, we have data that is slightly better distributed. We have instances of some classes that were not available before, as you can see. If these nodes were to train on their own, the best they would be able to achieve is 40% accuracy, and this one 37% accuracy. What we're going to see now is how to run it in a federation with Flower. Before jumping into it, I need to highlight that. Well, what about these two other components, Superlink and SuperExec? Where are they? I mentioned they are running another cloud in Germany. Here we can see, well, here I have the Superlink. We can see that there is nothing printing, except one warning, because nothing is happening. My myDREa nodes are not yet connected in any way. I haven't launched it. I have my SuperExec as well, and there is nothing happening because I haven't started the experiment with Flower Run yet. That's something I'm going to do right now. So how do I connect this myDREa workspace to the Superlink, which is here? So for that, I need to run a command that is called Flower supernode, and then I need to pass a few arguments. And the most important one is, this is the command I'm going to run. I have put it in a script, so it's easier to run, but you can see the most important argument here is where is the IP of my Superlink and the port. Remember, this is the IP I whitelisted earlier in the myDREa dashboard. This is a secure connection, so I need to pass a certificate that I have already prepared. And then there are other type of arguments that are less important for the demo, but one of them is called isolation, which is isolating the execution of the workload from the parent process. I can go into more details if you are interested, but for now I think that's enough to know. So if I want to connect it, well, I just need to launch this script. And for example, you see that, well, now there is a node that has been connected. By the way, I haven't mentioned, but this superlink would be something that the ID admin will be provisioning and launching and monitoring. So it's useful to see some of the logs here. Like I can see that there is a node connected. You can see that periodically there is a new message appearing here. This happens because the super node, in this case the first one, is periodically asking the superlink, is there a message for me that I need to process? And because there is no message, nothing is happening here. What I'm going to do now is I'm going to do exactly the same, and I'm going to launch the other supernode in this other machine. And we can see that another node was created. And the exact same thing happens. The supernodes in the myDREa workspaces remain idle because me, the researcher, I haven't started the experiment. And that's what I'm going to do right now, running Flower Run. So I go back here to my code, and I don't need to, as we'll see, I don't need to change anything. The only thing I need to to change or add is what we call a federation. This is a small block of a config file. So the format is TOML, but it's very similar to YAML, for example. Maybe you are more familiar with that. And what I need to pass is the address and the port that the super exec is listening to. Currently, these two are running the same machine. They don't have to, but for this demo, they are. That's why you see that the same IP I had before is here, and then it's listening to this port. Because only those that are authorized to interface with it can run an experiment, I need to supply my credentials. In this case, my credential is in a form of a certificate. So if I want to run this, if I want to start this, what I'm going to type is, now I need to type the name of my federation, which in this case, I decide to call it myDRE. It could be anything else. It's just a string. So the moment I press enter here, what will happen is that all my code, my client app and my server app and my config file will be bundled together, and it's gonna be sent to the super exec. So the client code and server code is gonna be bundled, and it's gonna be sent to the super exec, and this will be ensuring the code delivery mechanism gets started, so the code arrives also to the super nodes, and so they can do the training. So I'm gonna do this. So you can see successfully built. .fab is the naming convention we have. Now we can start seeing things are starting here. Started the run. And then very soon we're going to start seeing activity here. So you see round 1, sample 2 out of 2 clients. There are only 2 supernodes connected to the super link. These are the 2 myDRE workspaces. And therefore, that's what's happening. You can see here there is some login. You can receive an evaluate message with a unique identifier. And you can make this login as verbose as you want. You can make it more verbose with information about each intermediate step. If that's needed for your auditing requirements, you can do it. Let's say I want to see the code that the researcher sent to this machine. Maybe this is important for auditing purposes and peace of mind purposes as well. So I will just go to a directory called .flower apps. This is my name. The directory follows the name of this file. So it will be Javier. My project was called myDRE Seminar, version 1. And here I can see the code. This is the code that has been delivered. And it's the code that is being executed here. So, yeah, I think this is fundamental in order to be able to trace what's happening in these machines. It's important because, after all, we are using this myDRE workspace because our data is sensible, right? Otherwise, we'll have it in a random laptop, but because it's important data, it's running a secure environment. Now the run keeps running. You can see we are at round 5 out of 10, which is the default, but that can be configured. And we can see that our accuracy, even though we are only using 2 nodes out of the 10 in our real setup, we are already hitting 40% accuracy, which is higher than what, for example, this supernode could do on its own. If I let it run for longer, it will reach a much higher accuracy. Yeah, this is
Javier,
core of the demo.
We have a question.
Yes.
We have a question, Javier, from Bus. What happens when one of the supernodes crashes?
Yeah, so I will show you right now. If I cancel one supernode, yes, I canceled it. Nothing happens. So the federation doesn't crash. My strategy, in this case, for example, Fed average, it was configured. It offers very high degree of configuration, And for example, here is saying, oh, I need a minimum of 2 clients, which means a minimum of 2 nodes to be connected in order to proceed to start or to continue. In this case, you see everything has halted because now there is only 1 node. If I connect it again, for example, you see, oh, created node ID, blah, blah, blah. Now everything resumes. If the disconnection happens in the middle of when a task is being processed, like the training suddenly disconnects in the middle of the training, what will happen is that a failure will be reported. For example, you can see here that there are 2 results and 0 failures. How do you handle failures? By default, the aggregation algorithms from Flower discard those failures. But depending on the application, you might want to take them into account in some way. You can do that as well by customizing your strategies. Good question.
Thank you, Bas, for your question. I see you have deployed Linux VMs. Can that be done also on Windows?
So that's a good question. So we don't develop, we don't test this natively on Windows. Windows does offer the Ubuntu subsystem, the Linux subsystem, and that has worked very well for many researchers. But running it natively in Windows, for example, that's one of the things that in a pilot program or a support program is what we can look into. But for now, yeah, people have run it in Windows, but we are not testing our code on Windows because it's a different story.
Yeah, it makes more sense to have it also on Linux. And I see, we do have a UI, so it's a bit more user friendly.
Yeah,
the UI of Linux. Yeah.
While people think about questions, I want to also show something cool. For example, I finished running my code with default settings. What are the default settings? This is in a per project basis. Here I have only this. Let's say I want to override my settings. I want to do just 2 rounds instead of 10. Well, oops. I'll just do it like that. So now, and the run begins. I don't need to, restart the supernodes. I don't need to shut down or reboot anything. My second experiment is running. This time it will run for 2 rounds, but you can think that this can be extended to a more complex setup. Like, I want to run my workload with different hyperparameters. I want to load, instead of loading this local data set of X-ray images, now try to load this subset of images. This can be configured at runtime as well. And again, this can get logged into a separate file if that's what your application and your institution requires. You will see that this will end very soon because we set it to run for 2 rounds only. Oops. Well, it didn't. I think maybe I made a mistake here, but it's fine. Are there any more questions?
Yes, I see another question. Thank you, Bas. Is federated learning also possible for something like logistic regression?
Yeah, absolutely. So in this example, I use image classification because it's what I'm more familiar with and what a lot of people understand. But yes, you can do any form of learning, logistic regression. You can do a reinforcement learning if you want. You can do LLMs if you want as well. In the Flower website and the GitHub especially, you can find a very long list of examples. For example, this is the Flower GitHub. If you go to the examples, we have a really long list of examples. You can see, with a plethora of frameworks like FastAI, Hugging Face, MonAI. Here we do more image classification, pandas, and so on.
Could you share the link in the chat? Is asking.
Yes. Yeah, so
basically, to have this up and running, you deploy a virtual machine, then you open a few domains and also an IP address. And then basically you went inside the virtual machine on the command line, and then you ran Flower.ai. Flower run.
Okay, there was one step I didn't specify, but let me do it right now. So currently, what's happening? Okay, yeah. So what I did is I created a Python environment. My Python environment in this case is I call it test2 because it was the second time I tested, but it's a normal Python environment. You can think of like a Conda environment, it's the same. And there, the only thing you really need to do is to do pip install Flower. It's as simple as that. In the future, we're gonna provide probably a UI mechanism to facilitate this. But for now, if you want to test it today, this is the way to do it. It's just really three commands. Install, create your environment in the way you want, install Flower, and then to connect it, to run the supernode, this is the command, and then there are many arguments you can specify. In this example, I only specified a few because these are the ones that are the minimum needed for this example. In a more general setup, with these three, you will be enough. When it comes to starting the experiment, yes, you do Flower running. If you are starting with Flower and you want to get a sense on how to run things, the best thing to do is to run a command called Flower new. With Flower new, what it allows you to do is to create a project from scratch. So I create this in my demo. I put my name, and here it will ask you, okay, tell me what type of project do you want? You want a TensorFlow, a PyTorch, a NumPy, and when you complete this step, it will create all the code for you, and then you can edit it based on your needs. But in general, I would recommend going to the GitHub in Flower or reach out to us on Slack.
All right. Well, thank you, everyone. Good to see you here. And yeah, we catch you to the next one. Thank you, Javier.
Thank you.
Bye. Have a nice day.
Bye-bye.
Bye-bye.